Uh, let's begin. I have good news and bad news. Good news is I'm the only thing between you and lunch. Okay. The bad news is that I'll probably be over time. So, I mean, when the equations start popping up, if you guys just want to grab a quick sandwich or something and ignore me, that's fine. I'll completely, I'll understand. Anyway, so this is beyond matching, right? And we do have a hashtag if you guys are into Twitter, and if you want to hashtag with the talks hashtag, it helps me find all the snarky jokes you guys made at my expense later on. So without further ado, let's get going. So for those people who don't know me, my name is Alex Pinto. This is a fairly recent picture that I took. And I've been working on the intersection of machine learning, threat intelligence, security for a while now. So I'm a co-founder of a company called Needle. And what is a needle, you ask? And it's a, hold on, let me catch my breath. It's a SaaS-based autonomous threat hunting system, right? So we also leverage machine learning and threat intelligence, right? So that all the buzzwords are covered. I think our only saving grace is that no one in the founding team is ex-military or ex-IC, right? That's the only thing that keeps us apart from the jargon-hidden company. But anyway, the point what I'm mentioning is that a lot of this research was made available was conducted by me using data from Needle, right? This is not a talk about the product, but there's a lot of concepts here that are a part of the research that we did for it. So I just wanted to put it out there. And the focus of this talk is for you guys to reproduce these ideas. These are things you don't really need any machine learning or any fancy math, right? I think these are things that have been very effective for us to measuring our efficacy, communicating with customers about the results that we have. So anyway, what we're going over here, first of all, just a quick introduction, what I'm talking about when I talk about IOCs, right? Well, let's just try to classify words because words should have meaning, right? So we're going to talk about the highly effective analyst habits, right? And how do people actually leverage IOCs in practice, how they should be, right, to be effective, right? And then apply those ideas. Oh, if people were doing that, why can't we write code to do that as well and get to a kind of a nice, tight conclusion, right? And if we have time, we're going to talk about something, some interesting other analysis I have been doing. So anyway, I just want to let you guys know if someone here hasn't really worked with network IOCs before, they haven't integrated threat intelligence, I'm sorry, I'm going to spoil what's going to happen to you once you try to implement it, right? I mean, I apologize. Some people like to discover further on, like spend a few $1 million here and there. Before they reach the conclusion I'm going to show you. But anyway, it's fine. So if anybody wants to leave the room around, it's OK. So let's begin by the definitions, right? What I'm talking about here. I'm specifically, before someone goes not all threat intelligence on me, what I'm specifically talking about here are indicators of compromise and more focused on network-based indicators of compromise. So all our research, all the things we're going to be talking about are about network-based ones, right? And the idea of the IOC, right, is a kind of a tactical data point that you can, if those things are happening in my network or something like that, maybe there's a chance that something bad is going on with this machine. This has been related to badness in the past, right? And so it helps me in a tactical level to leverage the discovery of a system that was potentially infected, right? So it sounds good, right? The idea that I'm able to use these data points and I'm just going to run these through my logs and do a bunch of, see if I saw this domain or this IP address, and this thing will magically tell me what's going on. The problem is there are two big challenges right now with everything related to these data sets, right? And I've covered these problems on previous talks that I've did specifically on threat intelligence, right? And I've spoken to two of these, and specifically quality and curation. I mean, how good is the data, right? Am I consuming the right kinds of data? Is there overlap on the data that I'm ingesting? And you go very down into the rabbit hole very, very quick, right? So who has the time to consume these things automatically and to parse them and to vet them? A lot of different problems. And also becomes the thing about the volume, right, and the velocity, right? If a vendor comes to you, I have 7 million bad IP addresses for you. I have the biggest database of bad IP addresses. Assuming they're all relevant, the quality problem has been solved. How do you match something like that? How do you load that into your SIM? How do you load that into the firewall? These are problems that haven't really been solved yet, right? Not that it's a good idea to do that, but it just becomes like, when you stop to think about it, that doesn't sound like it should work on any reasonable way. And I think the biggest problem is, I mean, in addition to having good data and being able to apply it effectively and timely, is that those things are usually at odds, right? And this is what I think is one of the scariest things when we talk about IOCs, right? And I'm specifically talking about, I mean, I love the DHS, right? And I love the AES program. I think it's a great step in the right direction, but when they released the program, right, for threat intelligence sharing, they decided that, you know what, we're not going to do any curation because survey says, we talked to a bunch of CISOs, and they said it's more important for them to get the data fast than to get good quality data. Someone's going to have to do the work. Someone's going to have to validate this, right? And the fact that we have this tug of war, how soon do I need the data in? How much quality do I need for the data? Again, just makes this problem even more intractable, right? I'm consuming those things. I don't even know if they're good, right? How am I going to leverage action into those things, right? How am I going to measure if a match is good or not? So what happens is, right, and this is just a very long problem statement, that either we usually start by matching, right? We get the IOC data and we start matching against our logs, and then we immediately shut that down because that's completely useless. You just go blind immediately, right? And then people realize, okay, maybe these things weren't made for matching, right? Maybe those things were meant for contextual data, right? So then you have a different set of alerts, you have a different set of things that are being generated, and now you're using this data as something that can be as an enrichment, so to speak. Oh, I have seen this network detector or this endpoint detector flag something about this event, and oh, there's also network IOCs about this, so yeah, maybe I should pay attention. Or at least now I have a hint of what this thing might be like. So anyway, it's super bad, right? And I'm sorry if I brought everybody down, but this is pretty much the state that things are, right? When you're talking about, and I can totally get behind people going, oh yeah, this threat intelligence thing is crap, because this is what people have been trying to do. You go to a threat intelligence vendor, they say, yeah, just plug this in, it's super easy, right? It never is, right? And hopefully the people in this room, they kind of know that. So what make analysts effective, right? And what's this unspoken secret, right, of people who have actually, again, oh my God, now I have to work with this threat intelligence data. What am I going to make out of it? How am I going to make this useful, right? Is that, you know what, this is not a finished product. And again, the biggest, oh, this is just data, this is not intelligence, and people go on 15 long tweet storms about the difference. It doesn't really matter what you call it, but the point is that you get these things, and if you look at them as samples, if you look at them oh, okay, this is telling me about specific things that this actor is doing to create their infrastructure, then you start to, oh, maybe I can learn from this, right? Maybe I can see and I can derive, right? And I know it's a bad word, but I can learn from what this thing is and how this thing represents itself in the infrastructure that we have in the internet, in order to learn a little bit more than that, to extract higher level indicators or higher level TTPs, if you like, of what those things look like. And then not be so reactive, as in I'm waiting for the IP address, I'm waiting for the domain to get into my pipeline to match. But now I'm like, oh, I know that everyone that registers with this email on this Whois server, it's probably not going to be something good. So everything's connected, right? I definitely don't need to go through this slide for you lot, but I mean, the relationships are there. You can start to draw these lines, right? And you can start to understand how these things go. So the recipe, right, and everybody, oh, these highly effective teams who are hunting and are finding all those different things, it's a very simple kind of recipe. They start with, okay, we figured out something is bad. Let's analyze this malware. Let's find out who this malware is talking to and what sort of things that it's able to generate. Now, let's learn from where this malware is talking to, and let's find the associated infrastructure. Let's open our Maltego. Let's open our Palantir, whatever you guys, I mean, depending how much money you have, and let's explore this. And what are other points which are highly likely to be related to this as far as malicious infrastructure? Then we search for those IOCs and start our network, and we learn more shit that it's bad. Now, from these things, we analyze those things, and we go expanding until there's no more cycles to go through, right? And then you've looked at the whole infrastructure, right? You hopefully have a good containment policy. You didn't shut them down in steps. I mean, this is not an IR talk, right? But you're discovering this infrastructure. You're walking through this infrastructure graph in a way, right? And you are discovering all that this actor or multiple actors have and they're using at the thing. And then you publish and you publish a report of Frosty Penguin and you get a lot of sales leads, I guess. So let's see what we can do, what we can learn, and how we can try to translate a little bit of these ideas into some things, calculations that we can make, right? So first point is begin with this data collection experiment, right? So let's get a bunch of IOCs from your favorite providers, right? I'm going to go through an example here of this log collection, of this enrichment process, and we're going to go into more general overview, more general examples. So the idea is that since we know that everything's connected, let's do all these enrichment points. For IP addresses, let's look at the BGP prefixes, the AS number, names, passive DNS relationships. And for domains, of course, we also have the passive DNS stuff, but we got a lot of who is, what NS servers are serving this. So there's a lot of different things. A couple of years ago, I published a tool, a very, very clunky Python tool that allows you to extract IOCs from several different things, kind of normalizes it for you, and it can do some enrichments based on AS, BGP, stuff from MaxMine, right? And also passive DNS from Farsight if you're already a customer from them. So that could help, right? So let's look at a small example. And I'm using this, I'm selecting some things because I'm going to be showing further slides, like how this strategy makes sense in practice, right? So this is October, right? These are some of the rig people, some of the rig events that we had in October, right? And if you look specifically at the registered emails, there are two that are selected. There's our poor friend Rob Cross.me and someone from Yandex, right? And you saw some concentration there. We had these IOCs listed. They were contributed from multiple different parties. And we saw, oh, there's like 33 of them for Rob. There's like 15 for Mr. A, right? And when you look at this, you say, oh, okay, I can definitely understand that there's something going on here, right? So poor Mr. Rob Cross, he isn't really a bad threat actor, right? You're clearly seeing, if you're familiar with domain shadowing, right, you can see that this guy probably works in weddings, and he creates websites for people getting married, because you see it's like a name and another name. So it's probably, jackandjill.com because they're getting married. But someone took control of his account on GoDaddy specifically, and started to creating subdomains to host malware. I mean, Rob Cross per se is not bad, right? But since there's a lot of activity happening with his email address, all these other domains are showing up, and you go into the whois, you see that they're related to him. This could be a good indication that, well, you should pay attention to this, to whatever domain is on this guy, is registered by this guy, because there's a lot of history there of bad stuff happening, right? And the same goes for Mr. A, right? So Mr. A, this was not domain shadow. He was actually registering domains at the time, right? And XYZ stops. I mean, almost everyone is blocking those guys now, which are making those actors move to .space, .party, There was a string of .toys and .wang recently that was just disturbing. But the point here is that if you are confident enough that this domain is a marker, is an indication of compromise for you, is a strong relationship, you could allegedly just work out of the registration domains. Okay, let's just block every single domain that this guy has ever registered. Done deal, right? So, I mean, of course, the same principles would work for autonomous systems and countries. I'm definitely not picking on Russia, just happen to have the most connections there, right? And you can see exactly the same kind of pattern, right? There is a lot of BGP prefixes, and a lot of stuff was happening out of IT grad as far as rig hosting is concerned at that specific moment in time. So let's aggregate this. Let's look at specifically at rig again. And again, we could create these views, we could create these decision points for every single kind of threat that either you have classified yourself from the IOCs, or the IOCs gladly provided you this was rig, this was this, and this was that. So it kind of becomes, on some of those ways to aggregate, some of these pivot points, it becomes very easy for you to make a decision, right? So you see Stevie Malone there, got a lot of hits, a lot of different domains that were registered to this guy. So yeah, maybe Stevie Malone is something that I can. So Stevie's actually back recently, but he's doing Sundown now. He's not doing rig anymore. And when you look at AS numbers, right, the first one is OVH. I mean, I like OVH. I don't have anything specifically against them, but they are abused from time to time. I mean, every time. But I mean, the reason why I can't really say anything bad about them is because they have a team that actually responds, right? They will go above and beyond and try to shut these things down. But still, right, they're a hosting provider. If it's hard for you to spin up a host at a hosting provider, they're out of business. But then you see the Hosting Solution Limited, which might be known to some of you guys as king servers. These guys are terrible. These are bona fide bulletproof hosting. And IT grad, I mean, IT grad is not great. So maybe, right, maybe I should block hosting solution. Maybe I should. So you start to think about that, right? Maybe the threat intelligence is telling me something, right? I don't need to go to the IP level. I don't need to go to the domain level. Maybe there's trade-offs I can do. But then it becomes obvious that the context starts to matter. And you can't just take those decisions willy-nilly, right? If you look at the biggest offender for rig is .com. You're not going to block .com, right? That's going to be a very, very short history in the company that you work for, right? You're going to be terminated immediately after, right? But .info is, right? I would say it's neither here nor there. .top, you can just .pw, .xyz, but you see .com and .org are there. So just the counting the amount of bad stuff we see in an environment, in a grouping like this, it's not enough for us to make a good decision. But I mean, why do we look at this and we see, okay, of course blocking.com is a bad idea. It's because we know that there's a lot of good stuff on .com, right? So if you think of these as disaggregation metrics for each one of those pivoting points, for the bad stuff, for the IOCs, and you have a way to collect good data, and we'll get to that in a second, right? Maybe you can create a ratio, right? So it's like, what's the percentage of stuff that, according to my knowledge, according to what I have seen as an analyst, as a company, as an organization, is bad versus what is good? This is a simple ratio. Like, what's the percentage of things that are bad? There's a lot of, the PP is in pivot point, right? So it's not supposed to be scary, but it's just for clarity that this is exactly the kind of accounting that I'm doing. Right? The idea about good places, I know that's like, oh, but nobody sells good data. And that's one of the biggest challenges in security research right now that's trying to do this, right? My tips for you for trying to find that is that your data actually, your organization's data actually has a lot of information about what's good for your organization. And I know that sounds weird saying out loud, but think about it for a second, right? I have this outgoing beef with people who do behavioral analytics because they keep insisting that things that are rare are malicious, right? That's the only hammer they have, so everything is a nail. So they'll just go, oh, if it's a rare, if it's an outlier, then it's probably malicious and it should be alerting on it. That's not the case. Most of the time, that's not the case. But if something is too frequent, especially given, again, there's this thing called the base rate in information security, which means like there is actually the amount of machines or the amount of communications you have that are actually malicious are very, very, very low. There's a huge class imbalance in trying to figure out what's good or bad because bad doesn't happen that often, right? And this is what messes up risk calculations as well. So, but if something is very frequent in your network, the likelihood that that is malicious is actually very, very low because otherwise everybody would be infected by the same thing. So you can leverage this kind of ideas to try to figure out if everybody's going to this place, right, maybe it's not that bad. And of course, very shallow scoops of Alexa. Very shallow scoops, anything after 10,000, I definitely don't vouch for it, right? So let's look at those data points before and see how those numbers look, right? So again, this is from a sample of Needle customers, right? And I say that because when we talk about what's good, what's known good, we take into consideration their data, right? So IT grad was a whooping 87%. Right? So 87% of the information that the system had was of bad samples and not of good samples. So yeah, I think it might be okay to think about blocking this or alerting on something like this, right? But when you look at Russia, for instance, it was 5%. I'm like, oh, 5%, that doesn't sound too bad, right? And the .org was at 2.9%. But when you look at the base rate, and I think that's the thing that gives you the ground here, right? When you look across all different ASNs, right, that the customer went to, and what was the good stuff versus bad stuff in each one of them, this was like 0.6%. So on average, if they went to an ASA, there was a 0.6% of bad things, or the percentage there on that solution, right? But if your base rate is 0.6%, and what you have on the actual place you went is 87%, you're talking about something that's 200 times more likely to be malicious than the average place that you go to, right? And then that starts becoming relevant, right? So you see, comparing the .org with the TLD, it's okay. .org is a normal TLD as far as how much malicious stuff we can find, we can generate on them, right? Russia is right? It's like 10x, but 10x is not a big deal. And depending on where you are, depending on the kind of stuff that you go to, right? Of course, if you're a company that has offices in Russia, it's way, way more frequent for you to go to places in Russia than if you're not, right? So, and again, this is just the scary version of what I was talking on the last slide, right? I'm just, the denominator, I'm summing up all the different maliciousness ratios that I have for every single AS or WHOIS or something like that, right? And I'm dividing by the one that I want. So now I have a rating. Now I have how many X times this thing is more malicious than something else, right? And then I can start to care. Then I can start to, oh, if this thing is 2X more malicious or 200X more malicious, right? Maybe this is worth me looking at this. So this is just sample distributions of that, of this idea, just for we to do like a spot check if this idea kind of makes sense or not. So this is based on over 8 million observations, across different customers that we had. And we're looking, what's the distribution of the maliciousness ratings for ASN, right? And it kind of wants to do like a linear thing here, right? You see there's some bumps in the road, but please bear in mind that this is a log graph, right? So this actually, if I was to draw this for you on the actual like scale, we would have a huge bar and you wouldn't be able to see anything else, right? That would be it. It's really trying to do some sort of power law. So the absolute vast majority of the observations that we have are usually on things that are very low, between 0 and 1x of maliciousness of everything, right? we usually get a spike in the end, but this is an artifact of the calculation that we're doing, because if we have some place that we only know bad things about, it automatically becomes the highest possible rating. So you might get a spike there. Again, the internet is very big. You're not going to have information on every single IP address or every single domain out there. And you see the same kind of thing wanting to happen there on the TLDs, right? So that's cool, right? That's interesting, right? But how do we define? Yeah, yeah. I'll get there. So how do we deal with this, right? So we got a bunch of different numbers now. Now I was thinking about a match on an IP address, and now I'm thinking about all sorts of metrics that I can have for every single pivoting point. So I just created a bigger problem in a way, because how do I define the cutting scores? How do I define the weights? How do I define all those different things? What things matter more as detection points for a company or other, right? So the good and the bad news of that is that the solution is probably unique for each company, right? And based on the things that they visit, right? Of course, the maliciousness ratings will fluctuate based out of what the company considers to be good, right? And what is known bad for them, right? What is known bad from again, different IOC places, right? But you know, if you're thinking about the enrichment proposition that we were talking about, that what people usually do with threat intelligence, right? This becomes, at the very least, very interesting enrichment data that you can have in order to help leverage and to enhance the decision that you've done. So again, there's definite problems, issues in how do I weight all those different hundreds and hundreds of different variables to find out what is the better way to make such a decision, right? So if we only had something magical, that would be able to help us with this. So the point, and really the punchline here is, right, if you're able to, again, leverage all these signals in a relevant way, right, you're able to come up very easily with things like this, right, which is you have one point of information, which is the yellow triangle, that thing you knew to be bad, right, and that information just trickles down by the relationship that you have on that domain resolving to that IP address, right, so it paints the AS, the BGP red, paints the IP address red, right, and then you see that, oh, these other guys, which again, for us, we're looking at this looks obvious, right? But to a system that's looking at this pivoting data to find the relationship based on the whois, the way the whois is connected, right? The NS servers and the AS, right? It becomes relevant. You suddenly expanded your knowledge on what you can do with just a single sample of IOC. And you're now being able to apply that automatically to across the board to things that are related, right? So specifically on this guy, we had the relationship on the NS as well, right? And again, that became clear because you had the data point from that guy, and you were looking for that in every single other entry, every single other thing that you have. So yeah, so Shia LaBeouf did his magic. He obviously approves of the outcome. So just before I wrap up, I just wanted to say a different thing. This is a different outcome. This is a different piece of research that's still being cooked. But it goes about TIQ tests. And I'm not sure how many people are familiar with this earlier research thing that I did. But it was about, again, finding the quality of threat intelligence data. And at the time, I remember the first time I presented it, the first thing that people asked me, oh, that's great, so can you give my feed a score? And I'm like, oh, that's not the way it works, right? We're comparing them against each other. There's no way for you to see if a feed is good or bad in a vacuum, right? You probably would need to actually apply this to telemetry to be able for you to create your own informed decision if the feed is good or bad. Guess what? Ever since then, I got a bunch of telemetry. So I started experimenting on that and trying to think about what were the things that were relevant. So good or bad is still very loaded, but at least I think you can get to applicable or actionable or whatever fancy word you want to talk about it. So please don't read too much into these slides. I'm not avowing or disavowing any open source feeds. This is not what this is an example of the kinds of things we could be doing. So the idea here is trying to figure out from what's the ratio of threat feed matches on a specific telemetry feed versus how many things actually were treated as alerts, were raised by other tools or things like that, right? And the idea is pretty much how much the feed is getting right in relation to a potentially very flawed concept of what is actually an alert or what's actually an incident, right? This is very fuzzy, and everybody who does any sort of incident response will see why this is fuzzy. But again, you have to start somewhere, right? And if you're able to start doing those comparisons, you can start to cross-pollinate and see, is this feed helping me or harming me? Is this creating more false positives for me than I can potentially bother, right? And this is not a percentage of the data of the feed. This is a percentage of the matches that it generated. So one bad thing, one 8.8.8.8 can just crater a feed, right, as far as this efficiency metric is concerned, right? The even more interesting is by unique IOCs, right? So how much of the things that the feed uniquely contributed to my view of the world were actually good matches, right? Because that's when you're saying the absolute value of the feed as you're comparing it to what you got. So anyway, this is doable, right? This is doable with the kind of data, with the kind of things that you have, right? And this kind of metric, this kind of calculation has been available for us to figure out which feeds we should be partnering with, right? And I don't have any, it's a very situational specific, there's no real code to share, but I hope these gives you some examples on this specific part as well. The other part, I try to be as clear as possible on how the metrics are calculated, so you can try to experiment and see if it works for you. So I can't really improve the IR processes, right? Not even Charlie Buff can do his magic for that. So, and again, it ties to what's good and what's bad. So anyway, go have fun, do all this stuff, right? And again, don't badmouth necessarily threat intelligence, right? It's just raw data. It's not ready yet, right? It's like you're buying a potato and you're saying the potato is terrible, but look at all the good things you could potentially cook with a potato, right? And I don't know where that analogy came from. So anyway, let's automate, let's work with the data, and thank you very much. Sorry for running over and things like that.
And then you've got a few minutes for questions. Like your questions are between you and lunch, so.
Yeah. This is, by the way, this is what I do. I always go over so nobody asks me questions, right? So feel free to punch a very good one now. Yes, please.
How familiar are, so you do data science, so I'm sure you're familiar with like neural networks and that kind of stuff, right? So have you found any like novel areas of research in applying convolutional or recurrent neural networks to what you're doing? Because at the lab where I work, that's something that's like we're actively working on it today. I mean, there is a lot of existing academic or industry research on using those particular neural networks to do IOC context analysis.
Yeah. So the thing about convolutional neural networks or deep learning in any sort is that it's much more suitable for unstructured data. It's much more suitable for images, much more suitable for voice and things like that. And that's where we're seeing all these crazy advances now, and everybody has a little robot talking in their living room, right? So the thing about IOC data, the thing about specifically log data, right, is that it's already very, it's already processed. You already have it tabular. It's very easy to tabular. So neural networks are usually not recommended if you have it all neat like that. So tree-based models usually have a much better result. But having said that, I am very hopeful for applications of GANs, right, of adversarial networks, right, into trying to strengthen and work against either machine learning or traditional detection things. There was a very good paper from Hiram from Endgame recently, and he was doing like a GAN for DGA detection. So he was actually showing that here's our DGA model, this is the best we could do, and when we plugged in a GAN against it, right, so this is pretty much, so think about a machine learning model which is trying to detect DGAs, and there's another machine learning model whose job is to create stuff, create samples that this one won't be able to detect, right? There's a very specific way you code these things. There's a lot of weird feedback loops there, but this is a very active area of study now. And again, people are using this to improve voice recognition, all those different things. And I found that to be super interesting. Of course, there's limited applications, like everybody does their first DGA detector. Oh my God, I'm getting 99% of accuracy, and they think they're machine learning gods. So there's a lot of nuance on the results, but I found it incredibly, incredibly promising. Anything that has to do with entropy in security, there's definitely potential there, but I am really not an expert on that specific area of machine learning. Anyway, thanks. Good? Bad? Lunch?
Thank you.
All right, thanks a lot, guys.